Hello and welcome back to Math and Tea, the show where we talk math and drink tea. I'm your host, Professor Joseph, and hi, and this is our super duper ultra special little election edition. That's right, the presidential election is under a week away, and I've already voted, so stop sending me this stuff, people. Anyway, I wanted to talk about the math behind all of the polling that we see, because everyone talks about polling, but we don't talk so much about what polling actually is, and why it's important, and what this is, and what that is. Anyways, I thought I'd address some very common questions I see about polling. So here goes. Number one, polls don't ask every single person what they think, so they can't possibly be accurate. Now, that's not actually a question, that's a declarative statement, but anyway, I still see it a lot. This comes from a wrong idea of what polls are actually trying to do. Polls are not trying to ask every person in a population what they think. I mean, they could do that, but then they wouldn't be a poll. Instead, a poll is just trying to ask a certain sample of the population what they think, hopefully a random sample. So instead of asking all 39 million people in California what they think about a given issue or a certain candidate, instead we might ask maybe 1,000 or so. We then want to interpret what this particular poll means. We want to be able to say, well, we saw certain data from the sampled population, so what's the most likely thing we'll see from the overall population? Say, maybe we took our poll and we saw that 38% of the population supports a particular issue, and maybe 52% of the total population supports the issue. Does that mean the poll was wrong? Well, not at all. The poll, after all, tried to tell us what the sample thought, and provided it told us that accurately, the poll is perfectly correct. If the overall population supported the issue at 52% and our poll supported it at 38%, that doesn't mean the poll was wrong or even bad, just unlikely, really unlikely maybe. And that kind of leads into the next question. Number two, what do margins of error and confidence intervals mean? So a poll is information that helps us guess at what the overall population believes. However, any particular guess we make about the overall population is, well, unlikely to be likely. Here, let me explain. Suppose you are flipping coins, and let's suppose you flip 100 coins. What's the most likely number of heads that you see? Well, 50, right? And in fact, that's correct. However, you only see exactly 50 heads come up out of 100 coin flips about 8% of the time. So it's the most likely event to see, but it's still pretty darn rare. On the other hand, if we were to ask about what's the possibility of seeing anywhere from 40 heads up to 60 heads, that would be much more likely. In fact, that would occur a whopping 96% of the time. And it works the same way with polls. So if we see, say, a 4% margin of error and a 90% confidence interval, well, that means that about 90% of the time, the real answer should be within 4 percentage points of what the poll says. Now, to some people, this feels kind of wrong because it's treating the overall population as a probabilistic thing, when in fact, the probabilistic thing is our random sample. But that's not the right way to think about it. Instead, think of it like there's a whole bunch of polls. And if they all give 90% confidence intervals, then we expect them to be within the margin of error about 90% of the time. And as it turns out, the probabilities kick into gear so fast that even if you're polling a state like California with a population in the tens of millions, well, you don't actually have to sample that many people before you start getting a really good margin of error. You only need a few hundred. Number three, why do polls disagree with each other so much? Well, again, suppose we have a whole bunch of polls that all have a 90% confidence interval. Then not only do we expect about 90% of them to be within their given margin of error, but we also expect 10% of them to be outside of their given margin of error. Outliers aren't a bad thing. They are, after all, expected. The problem comes when they don't occur, not when they do. Number four, no, but really, why do polls disagree with each other so much? Okay, so if you've been following the national polls at all, you know that some of them are in complete disagreement with each other. There's some polls floating out there that have been consistently showing about a tied race with maybe a slight edge towards Trump. And there's some polls out there that have been consistently showing Clinton about 6 or 7 points up. So what's going on? Well, the truth is, okay, it's complicated. First of all, let's look at the math behind polling. The reason why the math work is that special word random. And, well, okay, it's really hard to get a true random sampling. In fact, it's really impossible. For instance, it's hard to get hold of some people, or some people just don't like responding to polls, or some people, well, kind of outright lie, or at least don't have a good idea of what they want. So maybe they'll tell the pollster that, oh yeah, sure, I'll go out and vote, and then they never actually do. Secondly, there's a surprising amount of psychology that goes into polling. The way in which a question is asked can change the way in which people will answer. So it makes it really hard to tease out, well, what do they really mean? Therefore, all polls are biased. That's right, all of them. Even that one you really, really like. All of them are. So what can they do? What pollsters try to do is to be consistent at the very least. That way, even if everything they do is biased, it's always biased in the same direction. Number 5. What's the best poll to follow? Well, there isn't one, because again, all polls are biased in their own way. So my preference is generally to stick to poll aggregators, people who collect a bunch of different polls and put all their information together, like the New York Times, Huffington Post, Real Clear Politics, and my personal favorite, 538. Their idea is that, well, if everything's biased, if we sample over all of them, then we hope that the biases will start to cancel each other out. Number 6. So why do poll aggregators disagree with one another? Aggregators have to make assumptions the same way that anyone else does. For example, at 538, they try to take into account the bias in a given polling firm, what they call the house effect. They try to measure it and then account for it in their averages. Now, other pollsters might do different things, they might not do that, or they might do it and come to a different conclusion. Therefore, you get a bunch of different answers. Number 7. What are simulations and why do people use them? Well, simulations are an attempt to model what an election actually looks like by, well, using a bunch of random number generators to determine whether or not an event occurs or doesn't. Now, as to why, well, this is the idea behind the so-called Monte Carlo method. The idea being that if you've got a whole bunch of interlocking probabilities, then it can be really hard to figure out exactly what the answer for the final probability is supposed to be. But maybe instead you just run a whole bunch of random simulations, and if you run enough, you expect to be close to the final correct answer anyway. So when a pollster or a poll aggregator says that a candidate has an X% chance to win, what do they actually mean? Again, this is confusing because the actual chance of winning isn't really a chance at all. Either they will or they won't. It's the sampling that's the probabilistic thing. So maybe another analogy is in order here. Instead of candidates winning elections, think of rainy days. If the forecaster says there's a 50% chance of rain, he doesn't mean, oh, well, there's some random happenstance that's going to occur of whether or not it rains or it doesn't. What's really going on here is that if you look at all the days in which they said there was a 50% chance of rain, well, it'll turn out that about half of them it rained and about half of them it didn't. You have to look long term. So let's bring this back to elections. Suppose that a given pollster has 100 candidates, and each of them they assign a 90% chance of winning. Well, what do we expect to have happen? Well, we expect about 90% of those candidates to win, and the remaining 10% to probably not win. That's all. Let's finish off with 2 quick definitions. Number 9, what is Bayesian statistics? Okay, so I have to make some very, very gross generalizations here, but typically in statistics, you start with the assumption of nothing. It's not until you get data that you can start assessing likelihoods and probabilities. However, with Bayesian statistics, you assume something right from the beginning, even if you know nothing whatsoever. You just start assigning probabilities, and then you use the incoming data to update and refine your previous beliefs. Number 10, what is oversampling? Okay, this one's a bit complicated because it can mean different things in different contexts. So one notion of oversampling comes from the idea that if you have a very large population and you're looking at a small subset of that population, well, your typical poll isn't going to tell you very much about that subset. For example, suppose you want to know something about the American citizenry, but in particular you want to know something about what Korean Americans think. Now, this is a bit of a problem because Korean Americans only make up about 0.5% of the overall population. So even if you sample 1,000 people, you're only going to have about 5 Korean Americans in that group, and that's not enough to understand what Korean Americans actually think. So what do? You go out and find more of them. You oversample. The other kind of oversampling, well, I want to call it a critique, but it's more of a way to dismiss polls that you don't like. So maybe you see a poll that has far more Democrats answering it than you think really exists in the population at large. then you might say that it oversampled Democrats and that that's evidence of bias in that particular poll. But beware, oversampling can be due to bias, but it doesn't have to be. Anyways, that was kind of a lot of answers there. I hope you enjoyed them. If you've got more questions, though, feel free to ask them in the comments down below. I'll try and check in on them and answer any more that pop up. Anyway, that's all for now because I'm out of tea again.